So we are in a just I want to kind of set the stage here and I'm going to kind of wax philosophical here for a moment. Ultimately, as we look at kind of the progress that healthcare has made over the past decade, it's really, really remarkable. I'd say like a decade ago, I was in my research was very focused on like numeric methods. I was using PyTorch and other tools to try and do some like, deep learning at the research level. But I didn't, I kind of lacked the compute for it. I was using techniques like Markov chain Monte Carlo to like calculate the coefficients of ordinary differential equations and trying to like match like clinical outcomes to just like pure numeric modeling. And now like computer vision really does play an outsized role in the clinical space, but there is kind of one assumption that we've never really fixed, and that is like when annotators disagree on a label, that disagreement like can't just go away, right? Because the fundamentals of training computer vision models is based on having an accurate ground truth. So on the right, we'll actually see this. This is a real CT data set in the FiftyOne platform. We can see segmentation masks are overlaid. And this is the sort of thing where exactly, what we consider to be the right answer, what is ground truth, is a matter of expert judgment. So my goal today is to kind of trace how we got here and then how that kind of assumption has become the pain point of what we now call the foundation model era. And then how can we develop a workflow to actually address it in a way that is structured, accurate, regulatory compliant, all of that. So here's how we're going to walk through this. Part one is going to be kind of how we got to this point, how we will say a problem we used to tolerate has become one where we can't tolerate anymore. We'll start where the term kind of ground truth even comes from in this context. We'll bring in foundation models. We'll land on the moment things start breaking. And then part two, we'll introduce a six-step pipeline in the FiftyOne platform that becomes a workflow to address the core problem we'll be framing. And then it is the big 2026. There is really becoming a place for agentic operations as well. And I want to be super clear here. This is meant to be a supporting mechanism for the software workflows we discuss here. But ultimately, from a usability standpoint, there are core agentic supported workflows that will allow us to do this. Yeah, sorry, I see the question in chat. Let me check the transcript options. I am sometimes a little bit out of my depth in Zoom. If I'm not able to turn the transcript on, I apologize. Let's see. I'll try one more thing here. Unfortunately, it doesn't look like that's enabled on what I see here. I do apologize. There is going to be a recording sent out of this. Let's see. Yeah, it doesn't look like it's enabled on my system to do live captioning. I do apologize about that. Sorry about that. Um, all right. All right. As questions come in, let's see. Again, feel free to use the chat and the Q&A menu. Um, I will try to get through as much content as I can. With me on the call, I believe, is my colleague Burhan, who will be helping with some of the questions as well. But I'll keep them open and we'll look at addressing them. Also, as I discuss various links, um, I'll be putting them in chat also. Again, I appreciate folks that are coming in to assist on the captioning front. I know that is, I'm sure, appreciated. All right. Okay. So we're going to begin with a bit of a narrative, and it shouldn't be too, it should be, I think, well understood by many folks on this call. But I kind of want to talk about the history of like what we mean by ground truth in this context. And again, like I think we know that in general kind of computer vision and machine learning in general, the phrase ground truth comes originally from like remote sensing and meteorology and like earth science, right? Like a satellite or an aircraft measures something from above, and like the ground truth was the real physical measurement someone took on the ground. It's by definition an objective fact, or we treat it as an objective fact. Um, about a decade ago, when I was young and naive and in school, and when deep learning really started kind of sweeping into the medical imaging community, this became a recipe for collect a big labeled data set, um, and train a neural network from it, and we borrowed that term of ground truth. But the reality is that, especially in medical data, um, ground truth is a yeah, I see the slides issue. Ground truth is only a partial judgment. This has happened before. Hopefully, the slide issue gets fixed here in a moment. Worst comes to worst, I will immediately stop sharing and then reshare. Oh, you said good. Okay, hopefully it's good now. Yeah, let me know in chat. I will keep chat open to make extra sure. Looks good. Perfect. Okay. Yeah, that happened before. Awesome. Um, Ultimately, ground truth is a judgment call. And when it's a judgment call made by an annotator in the medical community, especially an expert annotator. But we keep treating it like it's an objective fact because we have to, because some of the core model training metrics that we create around it have to assume that ground truth is uh, objective. So if we look at this on the right here, the whole problem in miniature can often be down to the idea of annotation, where annotation is often treated like an interchangeable, commoditized instrument. But ultimately, two qualified, radiologists can look at the same scan and disagree. And how often they disagree depends on their training, their experience, how hard the case is, um, and so forth. So this is not something that is unnoticed in the field. Like the field did notice this, and that's where this concept of label fusion comes from. So as data sets grew and they got bigger, two things became really clear. Number one is the concept of label noise, right? The errors, inconsistencies, the same scan that one reader calls benign, another can call malignant. But unfortunately, is the second aspect that the network um, learns that noise, right? So systemic annotation errors can get baked into the model. So because of that, there is a standard remedy. When several experts label a case, you have some methodology to kind of fuse their labels and have a majority vote or methods like staple that will estimate the most likely label while weighing each rate reader on like things like reliability. Um, the problem with that is it ends up erasing the cases that were disputed and where there was disagreement. Um, and this is an issue because having a pattern of disagreement can actually be a really good predictor of where a model will fail. Um, but the thing is, we ended up like averaging away that disagreement signal in order to have one piece of ground truth on the label. But disagreement patterns are useful because if people disagreed, the model trained off of it could affect its confidence and its ability to accurately predict as well. And that provides a very useful signal. So that brings us to the present, and the next big shift. So for years and years and years, not too long, like 10 years or so, right? The methodology was you train a task specific neural network from scratch on your labeled data. That era is now largely over. These days, we start from a foundation model. We have a large neural network pre-trained on an enormous amount of data, and you fine tune it. Um, and this has become pretty representative in medical imaging. We have Uni and Uni 2. This is These are trained on a million plus image patches. We have GigaPath. This is whole slide pathology. There's over a billion samples. We have MedSam2, which is fine-tuned off segment anything. We have BiomedCLIP, again, fine-tuned off clip. This is trained on, I think, yeah, like a 15 plus million figure and caption pairs, right? So these are orders of magnitude bigger than what traditionally individual medical providers could fine tune their models on. So the lesson here is like hardly anyone trains from scratch, right? You need to adapt one of these to your problem with a small local data set. Um, but when you adapt one of these fine-tune foundation models to your small data set, that's where labels become especially important. So basically, the old tolerable problem of being able to average away labels is now like not tolerable anymore. So during model pre-training, um, hundreds of millions to billions of samples, regardless of the size of your data set, like random labeling can largely error out. And that's why these large foundation models, they can be so robust and adaptable to different verticals. But we're not pre-training, we're fine-tuning on maybe, let's say 100, maybe 1,000 to tens of thousands of samples from like a single hospital or a single geographic area or a single organization. Um, in that size of data sets, disputed labels have real leverage. It can really affect whether models make a determination as to, again, whether like a mass is, say, benign or malignant. So really, this foundation model error that we're in is concentrating the problem. All that risk that used to be diluted across a really large data set is now packed into a small fine-tuning set where like every disagreement counts. And like there's separate issues. Like there's been recent research. I think there's a paper from MIT that suggested that even like the confidence language that the annotators use, like the radiologists, is like measurably miscalibrated. Like you can't trust how sure they say they are around their own confidence. Um, and again, this damage can like really only be like it's not visible on your own test set, right? Um, it only surfaces when like the model's is like applied to different data. So again, this whole ground truth problem has become a real issue in getting models that behave accurately in clinical setting. And unfortunately, this isn't theoretical. Like regulators are starting to pay attention. Increasingly, you're required to document how ground truth was built. Um, it might involve like because you need a test for bias across patients and patient subgroups. Um, there's frameworks from the FDA that requires that, as well as the EU, frameworks that like put medical AI in a higher risk tier. So, like, you can't ignore this problem. And some of the things you have to show are showing things on the right, like provenance, right? Who labeled what? You need to show performance broken out by subgroups and demographic subgroups. You need to show change control, right? What's the link between the model and where the data came from? You need to document how the model drifted over time. Um, so taking shortcuts it is really not an option, especially in this industry. So again, in this kind of area that I wanted to start the talk here, that's the documented like arc, right? We need to treat expert disagreement as information that we should keep in the data set. Um, and the core reason is because fine-tuning a model amplifies noise, it doesn't remove it. Um, but if we can treat that disagreement as a measurable property that can provide a signal and information to how the model ends up working, that can help us identify model failure modes and ultimately improve it by keeping that information as part of data set metadata. So that's largely where we come from. What does this actually look like? I think it's pretty well established that, especially in this field where subject matter expertise and ground truth is so critically important, commodity labeling is not really a thing, right? Because it takes experts to identify a uh, feature or class in the first place. So now, like, how do we actually record that qualified subject matter expert disagreement into our data set? And what I'll propose is a six-step ground truth pipeline. This is going to be done in the FiftyOne platform. If you're not familiar with FiftyOne, I'll introduce it in more detail here in a minute. The way I like to describe FiftyOne is it is a it's sort of like the IDE for managing visual data. It is an end-to-end platform for building visual data sets, examining them, auditing them for quality issues, computing qualitative and quantitative metrics, so like computing and analyzing the embedding space, um, filtering based off outliers and attributes like brightness, blurriness, sharpness, um, filtering your DICOM by all of its attributes, and ultimately evaluating your model predictions with respect to ground truth. Ultimately, though, these six steps are not inherently unique to FiftyOne, right? So FiftyOne is going to be the vector that I think these work really well in, but ultimately this is meant to be an adaptable workflow. So here's the workflow at a glance. I call them represent, surface, curate, fine-tune, evaluate, and operate. So the first is represent, is keep your different readers' labels in their own fields. So include separate areas of metadata for each label. And then surface and find the disagreements. There's a lot of, again, quantitative and qualitative metrics we can use to do this. Um, Number two is curate. Understand the quality issues in your data set. Clean up things like obvious label mistakes and duplicate samples. If there are samples that are not useful in your data set that are either spurious or unrelated that somehow made it into the data set, clean those up. Um, and then decide what's worth relabeling if needed. Fine tune, record the exact set of samples that you trained on, and then evaluate model performance. Um, Drill into each slice and subgroup and verify how the model performed. And then watch for drift and also watch for like key failure modes, right? Are there particular classes or patient classes or subgroups or demographics in which your model very clearly fails on? And then you can drill in and try to find why. And then lastly, um, operate. There are now ways in which you can use AI assistance to drive the whole process. So we're going to walk through each of these six steps, um, largely using the FiftyOne platform and what it supports. So, as a brief interlude, if you haven't used FiftyOne before, there's a couple ways you can get started. The easiest way is to pip install the library. So, if you are comfortable with Python and other tools, it is just a pip installable library. So, for those that have a kind of technical or coding background, here I have literally the FiftyOne platform installed. If I do pip install FiftyOne, that'll install the library from PyPy. And then from there, you can work with FiftyOne programmatically, right? So there is a Python SDK in which you can just start, importing the FiftyOne libraries, and then so much of FiftyOne can be interacted with programmatically. It does also include a UI that you can serve. Whoops, sorry, I'm showing the wrong page here. And then let me know again as I switch between tabs here. Let me know if my screen becomes a little bit weird and cut off. I know that's happened before. So the FiftyOne UI looks something like this. So here I have a data set here in the UI. I have a set of samples that are actually frames from video, so they're stored as images, and I have segmentation masks on these samples as well. So this is what the FiftyOne UI looks like, and there's a whole bunch of things that I'll be able to surface here as we go through these different steps. All right. So step one is ultimately pretty simple, but it's sometimes missed in the whole process. Is instead of screen cropped again, great. Okay, let me know if it is fixed. Sorry about that. Perfect. Awesome. Okay. I'll have to be careful here. I might end up just needing to kind of unshare, reshare the way I switch tabs, which is not what I want, but that happens. Um, the first is instead of relying on fused labels, actually represent them as separate fields in your data set. So, for example, in this example, we have radiologist A, radiologist B, and then radiologist C. Each gets their own classification um, within the data set. And we're not going to merge them yet, right? We're going to surface the disagreement in a couple of different ways. Number one might just be how can we structurally view the difference, right? So we might compute the embedding space based off of these different labels and visualize the embedding space in FiftyOne and then try to identify things like outliers. So imagine we have a set of labels in the platform, and I'll go to this cancer radiology data set. Here, I have 800 samples of um, uh, uh, potentially cancerous or non-cancerous samples. And we can see that there's the classifications overlaid here as well. There's actually a few sets of predictions, but I also have a nominal ground truth. It's actually right here, labeled here. And then what I've done is I've computed in the embedding space for this data set. That can be done in FiftyOne in a couple of ways. It can be done programmatically. It also can be done by running a method within the app called compute visualization. This allows you to either use a FiftyOne recommended model or a model you pass in to compute image embeddings. So this is just the raw embeddings, right? This is just the distribution. I can then color by all sorts of the DICOM data that I have here. I might color by body part examined. And as you can see, there's kind of the distribution that we see here. We see chest on the left, we see breast on the right. I could color by patient demographics, like maybe male and female. I can also color by label. So I think cancer right here is the core one. And at minimum, I can see the distribution. And already we see a couple things that might give us pause, right? This light blue yes is by far the most dominant um, representation in this space. So this is actually a subset of a larger data set of about 180,000 samples, and it's actually the same distribution there as well, right? We can see that it's by and large mostly yeses and a very small fraction of no's. So already any model that might be trained off of this could potentially have problems due to underrepresented classes, such as the no class or suspicious or even unknown. Um, in addition to that, um, this could be also be caused by the averaging of fused labels if we did the fused labels method by incorporating expert and disagreement into a single label. So one possibility here is to simply just have multiple sets of labels and compute the embedding space for each of them. And that gives us at least an initial chance to do things like identify outliers. For example, I can put this side by side with my data set and I can start to identify, okay, where are there areas in the embedding space that are clear outliers? And why might that be the case? For example, this down here, I could lasso and see, okay, this is a very, this is a darker image. These are all yeses in terms of what the ground truth thinks is malignancy, but maybe just like, this is either like ultrasound or blurry or something is causing it to be different from the rest of the samples. How might the model respond? If I reset my view, and then I go here. Here I see a cluster of a few yeses alongside, actually, I think those are nulls. Let me go back here. Some unknowns. Should be some no's here. Let me do this. What's nice is I can filter this as well. Or I can, oh, okay, they were just kind of hiding here, right? So I can also filter by no samples, and then I can also, say, okay, in this cluster over here where there are clearly no's interspersed with yeses, what might be the things in common and not in common that would cause them to be so close, so clustered together, right? So at minimum, the embedding space gives us kind of a qualitative way, even though the embeddings themselves is quantitative, when it comes to identifying potential outliers. From a other quantitative perspective, you can just start to examine data quality as well. So over here, if I open the data quality panel, you can get started and then compute things like brightness, blurriness, aspect ratio, entropy, and so on. And that'll allow us to get a distribution of where our samples are so that if there is label disagreement, I can then isolate that distribution, toggle on multiple fields, and then examine, okay, where did experts potentially disagree and why? So going back to this for a second, I guess I have to do this method and that's okay. Hopefully this is showing up okay. Let me know if it's not. Um, Ultimately, lesson one is store each label and then use quantitative and qualitative ways to isolate things like edge cases and overlaps in your samples, and then just toggle on and see whether those labels agreed or disagreed. What you can also do, and I didn't directly do this in the app, but you can also do like, very typical things like, hey, what is the confidence level on those labels? Now, again, that's always going to be a little qualitative because it's often relying on self-reporting from the labeler. This is just the underlying code of how you compute embeddings in FiftyOne. What's nice about computing embeddings is that aside from just seeing the embedding space, there are additional algorithmic methods that FiftyOne supports out of the box that allow us to go even further. So, for example, from the embeddings, you can compute what's called a similarity index and then isolate the most similar or most unique samples. What you can also do is you can use a method called compute mistakenness that takes model predictions and compares them to the ground truth labels and uses a k nearest neighbor approach to suggest, okay, where does the model such disagree with certain labels in otherwise high performing slices that it actually suggests the label might be wrong. So for example, if I go back to my data set here, we can see these methods like, let me get out of this for a second. Let's see if it allows me to sort by similarity. Oh, I need to do a similarity index. It allows me to, I'll do compute uniqueness real quick. So I can set a field here. I might say unique key. Everything else is optional. I can then schedule a run that then computes the uniqueness index in the background. This should only take a few minutes. While this is happening, I'll go back to my brightness. Again, just surfacing the data quality issues here. And if I go side by side, we can see, okay, there's clearly kind of two clusters of things here. Let me do this. Oops, sorry. Good quality, brightness. There we go. And if I want to say, hey, what are my maybe left tail of darkest samples, right? In the brightness distribution, I can see they're here. And again, right, this could cause potential quality problems among labelers. And this is again where I can see maybe where these labelers may have disagreed, right? If so. All right. And then going back to, let's see if that uniqueness run is done. Oh, uniqueness failed. Uh-oh. No logs collected. Well, that's helpful. Okay. Not sure why that happened in this case. demo gods didn't favor me on this particular example. Um, but what it would do is it would create a uniqueness score that I can then sort by. So for some reason that caused a problem. Not exactly sure why. That's okay. That could be something I could use the agent to troubleshoot here when I talk about that in a minute, which would be kind of nice. But I think you get the idea. Again, these are all different qualitative, filterable ways in which we can adjust our views and how we parse through the data set to see where disagreement might be cropping up in areas that matter. Okay, so that's pillar number one. The next, or pillar number one, and kind of item number two. Item number three is, sorry about that. Um, when you fine tune, this should go without saying, but you must record the exact subset you trained on and its lineage. Um, Basically, you need to keep a very detailed dataset version history with respect to each model training run. That can be done in a few cases. There are data version control things out there like DCS that are open source and you can use. Um, FiftyOne has a direct clone method, so at minimum, you can just simply create another copy of the dataset and tag it with a particular model run. On top of that, um, uh, that can be done in like open source FiftyOne. In addition to that, the enterprise version of FiftyOne, so the version of FiftyOne that like companies tend to buy, does have a full lineage tracker that we call version history that can be quite important for regulatory reasons. So for example, within my cancer data set here, if I go to data set history, I can take snapshots of the data set at different points when labels have been applied, removed, when models have been trained. So I might call it, pre-model train, June 2026. That allows me to create a snapshot of the data set. Why is this not working? Oh no. Let me try this one. Let me try the full thing. Snapshot June. Worst comes to worst, I'll show you an example where I know there's definitely snapshots on it. There might be a small permissions here. Sounds like a readability problem. Let me go to a different data set. This is not going to be a healthcare data set, but you will get the idea. So in this data set, which is a self-driving data set, if I go to history, we can see this full snapshot history here. Um, it creates a very Git style work tree. And then you can browse into a particular um, version of it, which itself is a shareable link, a link you can clone, you can roll back to, or you can just go back to the latest version if needed. So again, this is essential for kind of change management and maintaining a historic trail of what you've worked on. So yeah, sorry, I think there might be a permissions issue in my user that prevented me from creating data version history, but I see I got it working there. Okay. All right. Okay. So step five is going to be evaluation. Um, what you need to do here is you need to ensure you have a structured way of evaluating models with respect to each label. Because again, we are setting up a ground truth that we want to ultimately verify as being correct, but not with 100% certainty that the ground truth is correct. So once you start evaluating model predictions with respect to ground truth, you can start evaluating things like precision, recall, F1 score, and then um, rescore each data set based off of either model results or potential label mistakes surfaced by models having strong disagreement. So Couple ways this might look like. Number one is you can directly run foundation models against your data before you fine tune your own model. And that could result in a first pass of which you could evaluate disagreement. So going back to my data set here, FiftyOne has a feature called auto labeling that allows you to use foundation models as a first pass. So if I go here and I go to auto labeling, I can auto label the data, choose a target from the data set, choose a model, choose the detection type. So normally in medical, it would either be classification or segmentation. Choose either a zero shot or fixed vocabulary model. If I choose zero shot, again, I'm using SigClip probably isn't going to be a great choice here just because it's not domain focused enough, but that's what I have here. If it's zero shot, I'd add my own classes. If it was a fixed vocab model, you would select, the classes to choose from. You would set a minimum confidence threshold, maybe like zero point 0.5, and then initiate a run. And what that does is that creates a set of labels that then you can evaluate with respect to your ground truth. Again, whether this was foundation model labeling or like a model you've trained off of your ground truth labels. Either way, you can start to evaluate what the core evaluation metrics are with respect to what you think is your ground truth. So for example, I have this field called cancer pred for predictions. I have another field here called cancer ground truth. Oh, sorry, it's over here, right here. And then if I go to model evaluation, sorry, I have it in my local version of this. Let me flip back over to my cancer radiology. There we go. If I look at my model evaluation panel, I can see some of the core eval metrics like confidence, precision, recall, F1 score. Now, this example is a little bit not misleading, but the fact that the classes are so binary um, is a little bit different than other classes out there. But either way, I can click and zero in on the cases that my model thinks is one label or another, and then visually identify, okay, what might be about these that have caused failure modes. Same thing with my confusion matrix. I can click into a cell on my confusion matrix and surface disagreement between both the model and potential labelers or auto labels, where I can see, okay, here is the intersection of where, ground truth says specific, suspicious, but model says yes, or other way around, right? And then I can identify and examine further. There's a section called scenario analysis, where you can create a scenario based off a particular field or slice, or maybe patient demographic. So maybe again, there might be a demographic of patient weight. And then what I could do is I could, maybe patient weight is less than 200, for example. And that'll again create a filtered slice based off of that, where precision, recall, F1 score, class distribution are particularly isolated to that field. So again, the goal here is to kind of operate off of the theory that accurate data and accurate ground truth is going to be what moves the model performance more than model architecture itself. Now you'll notice that everything I did here was kind of with respect to lots of clicking around the app, kind of using SDK methods here or there. There's definitely a learning curve for this type of software, right? Despite kind of the power it gives you to really analyze and understand your data sets. The good news is that agentic capabilities are getting better. Now, obviously, in the industry that we're in, there are regulatory barriers to some of this under certain circumstances, but ultimately being able to incorporate text-based large language models can be useful, if not just for driving the ability to work with FiftyOne in uh, in a way that allows you to like onboard yourself while you're actually doing the work that you need. Um, so for that reason, we have invested very hard in recent months on in a couple of areas. One is an area called FiftyOne Skills because the computer vision domain is very specific. And our software has a very specific SDK, but a powerful SDK. We've invested in creating skills that you can import into your harnesses like Claude and OpenAI, Codex, ChatGPT, and others. The skills themselves are open source, and Burhan just linked it in chat. And what's nice is that again, if you understand the workflows and you just need to learn like the language of FiftyOne, skills are a really good way to tell your harness like, hey, import this data set, filter it by this criteria, compute uniqueness scores, sort by most unique samples first, for example. So as an example here, if I'm going to switch my screen over for a moment. If I open up my Claude terminal, give me 1 second here, and I uh, look at the skills that I have loaded, I have all of these FiftyOne skills and capabilities that have been loaded in. And fundamentally, what these represent is context that's been pre-baked into my agent so that when I prompt it to do something, it'll just load the skill and it really has what it needs to interact with the SDK. We've gone a step further and we've also implemented some of this into the UI as well. So if I go back to my system here and I go into, we'll say my cancer radiology data set, there is a section in the top right that says FiftyOne agent. And largely what this is it is a way to use FiftyOne skills agentically within the app. So we can actually see here, if I click this skills tab, I see all these skills already loaded. And at minimum, I can tell it again in natural language what I want. We can see that the default, in this example, the default models is Claude Opus 4.8. And I might see, hey, talk about the data set distribution, relative class balance, and I'm gonna be a little vague. We'll see if this works. Potential edge cases. And then you'll notice that what the agent starts doing once it thinks for a moment is it'll start actually loading in those skills, and you'll see kind of in real time what it does in the foreground while it might be off doing other things, right? So it's counting the values, it's getting the field schema, it's invoking tools in the process, again, these skills here. What it's ultimately reporting back is the field is a little bit messy. Um, because this is DICOM data, it has a lot of metadata areas it can work with as well. I think the edge cases thing might have, thankfully, it's only an 800 sample data set, but the edge cases aspect might cause it to be doing a little too aggressive with the counting, and that might cause the agent to slow down. While that's happening, if I go to a different tab, maybe I'll go into the total segmentator data set here, and I open up the agent here. Might maybe open a new conversation. Notice that when you open this, it can say there's various things it can prompt for as well. So for example, at minimum, maybe I just want to import more samples. How can I import new samples, right? This is a pretty typical question. Or maybe how might I export the data set? The 51 agent will process. Looks like it's still going on the other one. Again, it'll load the skill. And then sometimes it'll prompt for new ones. So it'll say, hey, is it media only, media plus labels, labels only? What format are the labels in? Where do they live? And ultimately, what it'll happen once you kind of prompt down the line is it'll open. I need access to there we go. It'll open this import panel and then guide you through the process. Same thing with embeddings, same thing with uniqueness. It'll connect to both the 51 SDK and necessary panels in the app. All right. Oh, it's trying to populate this value here. I'll do one more example because I think it'll be helpful and it'll be on a slightly different data set. I'll do this one here. Is especially when it comes to the kind of curation and filtering aspect on this, you might say something like, especially for the curation aspect, is filter data set by 50 brightest samples. And again, this is on a different data set that I know is much more structured. But again, it's a good way on how you can just use natural language and without having to know the exact like way and you would construct the view stage, it'll just do it. So here's a good example. This created a new view stage. And here we can see like the 50 brightest samples in the data set, like so. So again, it's a good way to start working with 51. As Burhan mentioned in chat, the UI-based agent is enterprise only for now, but the skills it ultimately relies on are OSS. So it takes a little bit more of work. You would need to like, install the skills from the skills marketplace into your like coding harness like Claude. But generally, when you work with 51 open source, you work with it more programmatically anyway, just because that's how you generally interact with open source 51. One more thing I wanted to mention as well, and I want to close the loop because remember, everything we're talking about ultimately is ground truth labeling. Um, and notice this is still trying to go and like, hey, prompt me to like make some CRUD operations on the data set to clean it up. I'll go ahead and close this out. One thing I want to mention is that, ultimately like annotators and machine learning engineers that they often take up different roles and they're not always doing uh, the same thing. Um, Let me fix my Zoom here. If you do need to make one-off label changes or start structuring your annotation processes, 51 does support labeling in app. So if I open up a sample like this, so let's say like we know for sure that like this is a malignant sample. There's an annotate button over here on the right. And from here, you can add a schema such as your annotation ground truth. And in this example, it's pretty easy because it's a classification set. And then from here, you can edit your classifications in this example, right? So under annotate, whoops, sorry, give me active fields. Sometimes you need to on or off. We go back here. No labels to annotate. I thought I just did. Hold on. Classification, 3 attributes. Oh, I didn't define the classes. That's why. Yes. Maybe. No. Suspicious. Then why is this not showing? It's showing here. Let me go back to my other one with the segmentation masks. That might be a better example. I don't know why that classification wasn't cooperating. So with this one, the segmentation mask, this is probably a better example. Even under annotate, again, I can add the schema. Oh, how to show this. Right here, with one hidden fields. Nope, this is active. Thought I set that up. Cancer, ground truth. Okay, like before, I'm going to jump to a different data set. Again, just to show you the example. If I open up a sample, I put it under annotate. If I set up something like detections, again, these become elements that you can directly change. If it's classification, I can add a new field. So maybe was the issue that I did here, actually. I don't know why it wasn't working in the other example here. Sorry about that. But again, there is in-app annotation. I don't know why my classification was failing there. Both detections, classifications, seg masks are things you can edit here. All right. So again, without totally trying to break the demo, I'll try one more time here. Let's see, classifications, it's on. Primitives. I'll try quickly just refreshing the page just in case. Select. Oh, that's because there's none here. Okay, that's why. Sorry. Let me go back for a second. Um, yeah. So I was trying to select cancer ground truth and it wasn't showing. Okay, let's do cancer predictions. That should be it. Yeah. Let me try one more time. Say cancer predictions, set up, classification, scan. Yes. Save. Yes, there we go. Okay, there we go. That's because one of my fields wasn't populated properly. So for example, again, pretend this is ground truth. Again, you can set the label accordingly. You can set a relative confidence threshold if needed, and it'll change and adjust accordingly. Okay, glad I was able to close the loop there. You can also add tags. So maybe this is tags and this is like, you can add a radiologist's name, ID, review, something like that. All right. Let me reshare. Or I'm going to do another stop share reshare to close the loop here. Okay. So where does that place us? Ultimately, it becomes, I would argue, an observability problem, right? So label consensus needs to be something that you can compute, recompute, store separately, version, and not try to hide through like having some sort of fusion or average, because in model fine tuning, that disagreement actually makes a big difference in downstream model performance. Using tooling like embeddings, uniqueness, mistakenness, similarity, data quality metrics like brightness, entropy, blurriness, and so forth. Um, it allows you to really start to drill in onto, if there is label disagreement, what are the slices of the data that it actually disagrees on. And then one more thing just to emphasize is that these workflows like aren't inherently specific to 51, but 51 like makes it a really powerful platform to be able to implement them, right? So we're not opinionated insofar as you have to use these workflows in 51 and it must be in that order. 51 is extremely extensible through, if you've ever looked at the 51 SDK, it's extremely composable, which basically means you can like build operators and plugins very easily on top of it. Um, and then with skills and agents and MCP support, again, if you're a subject matter expert in your field, but you just like aren't fully up to speed on like the 51 objects and methods and arguments that the software uses, you can use these skills to assist you. You know, hey, I want to reach this end result now. Let's actually, get there with the tool, but you don't have to, know each and every piece of the SDK, before having learned it. All right. This is a reference slide. You'll get this in the follow-up email. And then lastly, what I'll actually do is I'll stage this slide here. And then I'll be happy to take or talk about any final questions or discussion points. Um, Number one is the 51 docs are a great place to get started. In fact, if you go to the docs, like if you go to the docs homepage, there is this medical imaging getting started guide. So if you go to docs.51.com, which is where this QR code leads, and again, if this got cut off, I'll reframe in a second. There's this medical imaging guide, which walks you through importing DICOM data sets. Secondly, and again, let me reshare here just in case. If you're interested in the MCP, agentic work, the anything skills related, the lead developer and kind of spearheader of that part of the platform, our colleague Adonai, will be leading a workshop June 17 that is all about developing with 51 and developing computer vision workflows using agents, MCP, and skills. Adonai's a rock star. He'll do. It'll be a great workshop. Super excited. I'll be attending it myself just because I'll have a lot to learn from him as well. It's definitely something worth attending. But that being said, again, thank you so much for your attendance and for you bearing with me as a couple kind of screen share and demo things had to close the loop on it. Um, that being said, happy to take any final questions that come in. I know Burhan has been an absolute pro addressing these in the chat, but if there's any other discussion points, items you'd like to talk about, I kind of have a, discussion question here. Basically, if anything, you could just comment in chat if you'd like. Where does your pipeline discard disagreement and where would keeping it change the result? I think that can be really useful because if you're losing that disagreement signal somewhere in your computer vision workflow, um, in what way would keeping it like either change the result or at least give you more insight on how your model might improve? All right. But that being said, I will stay on for another few minutes. If folks have any questions or any final follow-ups, feel free to let me know. Otherwise, enjoy the rest of your Tuesday. And yeah, also, if anyone went to CVPR, forgot to mention that. Hope you had a great time there as well. I was in Denver this past week along with Burhan and a whole bunch of others of the Voxel 51 crew.